I'm a product manager at Redgate. I used to work on the SQL Source Control tool, but now I'm more focused on continuous integration, continuous delivery, automated processes that can help you develop databases and have more confidence that what you're deploying is what you expected it to be. So the goals for today. So I'm going to cover why continuous integration, why automated build and test, and more importantly, how to automate the building and testing of your database. I'm not going to focus on application continuous integration. There's more documentation about that. It's more widely known and more widely understood. But for databases, it's a different story entirely. I'm going to cover the tools. I work for Redgate. I've worked on a number of tools in the SQL Developer Bundle, and I'll be covering a number of these during this presentation. And obviously, you don't have to use those tools, and you can find alternatives. But obviously, from my point of view, it's better if you do. There will be a demo, so there will be a lot of demo, because my goal is that by the end of this session, you guys will be able to go back and in the same time that I'm going to present this, you'll be able to set up automated build and test for your databases. So because there are a number of slides as well, and the session lasts about an hour,
that's why I come.
I'm going to try to demo how to get it set up in less than 30 minutes. I might not succeed, but that's my intention. But to make it harder, please feel free to ask questions. That will delay it even further and make the challenge even more challenging. So where does testing happen? So we have various stages where you might want to, various stages of development. So you develop, you pass it to the testers, then I've just given it away, and then it gets deployed to staging, and then eventually to production. So where does testing happen? And the obvious answer is it happens in the QA department, because these guys, they're employed just to do testing. However, it is a bit of a trick question, because testing isn't just done in QA. Testing is done everywhere. It's done in production. So once you deploy to your users, and they try out the software for the first time, they are testing your tools. They're evaluating your tools. They might be using it in production. You push a new version, they find a bug, and effectively they are doing the job that you should have done prior to that point. Staging, maybe you have a DBA or some ops team. They're testing as close as possible to what's in production. They're running through those vital tests to ensure that the likelihood of a successful production is there. So another point I'd like to make is that the cost of finding a bug and dealing with a bug goes up significantly the further you go to the right. So if you do find a bug in production, the customer finds it, that's already bad because your reputation's at stake. The customers aren't going to be happy. They have to report these back to your support team, who will then try to reproduce it, and maybe there's a sort of conversation that goes on there. Goes to maybe some third-line support, goes back to maybe QA or straight to development, it depends on your process. Once they fix it, it goes all the way back up to production. Likewise, if it's found in staging, there is a bit of a chain there as well, but not quite so bad as production. If it gets found in QA, then it's pretty much testers raising a bug in your bug tracking system. The developers find out about it, they fix it, and it goes back to QA again. But ultimately, the place where you want to find bugs is development, because the people who are finding the bugs are the people who are going to be fixing the bugs. There's no additional inter-team interaction that needs to happen. Customers don't have to talk to you, you don't have to talk to them. You find a bug and you fix it. So that's really the optimal situation you want to be in. Also, the changes will be more discrete. When you deploy to production, you've probably got 6 months worth of changes that are all bundled in there. You shove it out into the world, your users will try out various features and they'll come across an issue. They'll report it back and you have no idea which of the 100 changes you've made is actually the cause of that bug. You're going to have to do some troubleshooting. That's more cost, more expense for your organization that you would ideally want to avoid. So because the changes are more discrete, so they're obviously easier to find in development, that comes at a cost as well, because there's an increased frequency of change. So you make a change, and immediately, if you went through a complete test cycle every time you made a change, it just would be completely impractical. You're not going to run through your whole regression suite every time you've committed something to source control in development. So you need a solution for that, and the solution is automation. Continuous integration is another word for automated build and test. And I'd just like to have an idea of how many of you are doing continuous integration in your organizations. Not database, just continuous integration. And how many are not doing any form of continuous integration? Okay, so I would say the majority are not. So that's interesting stat. Okay. And of course, how many of you are doing database continuous integration? How many people are trying to build or test your database in an automated fashion? That's great, actually. I'm surprised by the numbers. That's good. So, what is continuous integration? So this definition comes from Jez Humboldt. He works for ThoughtWorks. They do consulting, and he wrote a book called Continuous Delivery. And he's defined continuous integration as a practice designed to ensure that your software is always working and that you get comprehensive feedback in a few minutes as to whether any given change to your system has broken it. So that is the holy grail. So you make a change and you commit it to source control, and immediately you find out that there's a problem. Or you find out that there isn't a problem, and then you can just carry on your development being reassured that the chances are that if it gets deployed to the next level, your customers will not experience any issues. So that's continuous integration, but what is database continuous integration? What does it mean to continuously integrate a database? And I would say that database continuous integration is a practice designed to ensure that your database is always working and that you get comprehensive feedback in a few minutes as to whether any given change to your system has broken it. So what I've done there is I've just replaced a word with another word and added database in front of continuous integration, because your database code is code. So there is no difference. You shouldn't be treating your database code any differently. If anything, the database code is more important because it deals with your data, and the data is valuable, and if you lose data, then it's very hard to get it back, and you don't want to be in that situation. Whereas code, you can just redeploy. You can just copy over the faulty code with some new fixed code, and you're back to a working environment, whereas it's not quite so straightforward with the database. So this is just a diagram of how it works. As you can see on the left-hand side, you have a team of developers. They're working on their own sandbox individual databases. Of course, you could use a shared database as well, and some organizations do. In fact, most of them do. But the important thing is that you are committing changes into source control, and it kicks off a process. So you have a build system, and there are lots of build tools out there, and that will monitor your source control repository. And every time it sees a change, it will kick off a process. And that process does a build and test. So we've tried to depict the database and the application code in the same box, in the same package there, and as well as in the testing. And the feedback loop comes back to development, because it's a development-only process. But I haven't really described what I mean by build. So what is build? So build for application code is quite simple. You compile it, and it builds. So it's fine. And sometimes code doesn't compile, and it will fail at that point, and you'll get feedback very quickly. But more often than not, the developer will have found that out before committing to source control, and it will compile, and it will be ready for testing. But what does it mean for database code? Because databases, you can build databases. You might have a new customer or a new installation, and therefore you need a database creation script which builds a database from scratch. But that's only applicable the first time. Most of the time, you're going to be deploying to an existing database, one that's been there for a while, and you're just taking it from version 3 to version 4, for example. So you need upgrade scripts, not creation scripts. And more importantly, and this is the challenge, you need to preserve the state of the existing data. You can't just wipe the old one and replace it with a new one, which is what you do with the application code. What is test? So you've built it. Let's test. I mean, this is more self-explanatory what test is. For .NET, there's a tool called NUnit for .NET testing, very popular, open source, so everyone uses it. It can be used on a developer's machine. So a developer is highly strongly advised to run the unit tests on their local machine before committing to source control, because if they do it the other way around, anything they commit could be updated to other developers' machines, and that could break the system for them, and they wouldn't be popular in that case. But it's very common to run the same unit tests, or maybe a greater superset of unit tests on the build server, whereas a developer might just run a small segment. So the database. So T-SQL-T is an open source framework for testing. It's exactly like NUnit. It's designed for testing on your local machine as well as continuous integration servers. It's open source as well, so it's free. You can download it today and you can get up and running. There are some examples on the T-SQL-T website. It's designed specifically to test SQL Server databases. And Redgate has a tool, SQL Test, that provides some integration into Management Studio. So if you just get SQL Test without that, you can use it, but you just have to write some code to write the tests and to launch the tests, whereas we provide a little UI that I'll show you later because Steve somehow didn't manage. Are there any plans to integrate it with Visual Studio? Yeah, we're monitoring Visual Studio very closely. So most database developers are using Management Studio at the moment. There are a small number that are thinking about Visual Studio, and if we see a shift, then obviously it's good business for us to be where the customers are, and we will make that change. So SQL Prompt is a tool that works in Visual Studio as well as Management Studio. But yes, yeah, we will move more functionality across if the market moves across first. So these are the tools that we'll cover today. Some of them are Redgate tools, some of them aren't. TeamCity. TeamCity is a build server. A show of hands for who uses TeamCity or whose organization uses. Okay. But TFS has continuous integration as well. It's called Team Build, I think. Who uses that? Roughly the same. That's good. There are some open source ones like Cruise Control, although that's no longer being maintained. You have Hudson and Jenkins. So Jenkins is the one that seems to be growing the fastest at the moment, in terms of the free ones. And there are a number. There are probably a dozen popular continuous integration tools, some of which are free, some of which aren't. We use TeamCity at Redgate, which is why I'm using it here.
Yeah.
There's a SQL automation pack, and that's a bundle of resources that we provide at Redgate, so that's new. We released that last week. And if you go to our website, you'll find a link to it, and you'll be able to get the various resources to get you up and running. And we have MS Build scripts, Nant scripts, we have a TeamCity plugin, and this is all just to make it very easy for you to start doing automated build and test for a SQL Server. So I'm going to cover some SQL Developer Bundle tools as well. SQL Source Control. It's very hard to implement continuous integration unless you first have your code in Source Control, because that's what the CI tool is monitoring for changes. So you need your code in Source Control. SQL Test, if you want to do testing, SQL Test helps you write the tests. Obviously, it's using the T-SQL-T framework under the hood. Integration environments try to be slightly more realistic than development environments. Development environments are usually the bare minimum schema with a bit of test data. As you get closer, that diagram I showed you where you have test, QA, staging, and development, you've got a progression of increasing realisticness of databases and environments and configuration generally. So you want to take an extra step and try to maybe have as much data in your integration environment that you might have in production. If you can restore a production database and use that, then that's great as well. But if you can't, and many of you have data sensitivity requirements, then Data Generator can get your database to the same volumes. And SQL Doc is another tool that integrates quite nicely into a continuous integration process to allow you to get always up-to-date documentation on your database. Right, I've taken up 20 minutes, which leaves me half an hour to do the demo. And the demo I'll create a project in TeamCity from scratch. I've cheated slightly. I've installed TeamCity, because that would be otherwise 10 minutes of watching this progress indicator move across the screen. I've also installed the TeamCity plugin, which is just a question of copying a zip file into a location, so that's really trivial. So I haven't cheated very much. So that's my starting point. So I'm going to create everything within TeamCity from scratch. I will use Redgate's SQL continuous integration plugin, which is equivalent to the Nant scripts and the MS Build scripts to perform various tasks. And one of them is just to keep a database up to date on every build. And there are a number of reasons that I'll get into why you might want to do that. Run TSQL tests, that's unit testing, that's part of continuous integration, that's the test part. Generate data to make it more realistic as an integration environment, and generate documentation because it's nice. I'll also be generating the deployment scripts. So the whole point of build is that you create build resources, build artifacts that you later pass on to the next stage. And for databases, as I've covered before, it's the creation script for new installations and the upgrade script or upgrade scripts if you have multiple versions in the wild, so for databases. So that's the deployment scripts. Okay, let's try to do the demo. So this is Management Studio. And what else do I need? I have Visual Studio just because applications are more than just the database. So I'll just bring that onto the screen I'm not really going to do much with Visual Studio today. And Tortoise. So I'm using Subversion as my source control system, but that's because it's very easy to install the Subversion repository on a laptop. GFS is a bit harder, but whichever system you happen to be using, you would just use, because we're not going to tell you which one to use because you've probably already got one. Who isn't using source control here? A few people have raised their hands ever so slightly because they're probably embarrassed, and so you should be. So database. So I'll show you the database that I'll use. So I've created an entirely fictional character to do this, and he will be called Steve. So this database has objects in it. So this is the SimpleTalk backend database. So it has tables that like articles and things like that. We have an application for that too. So if I bring Visual Studio up, this is the SimpleTalk web application, ASP.NET. Let's show you F5 to launch that, and of course it's launching on this one over here, and there you go. So do you all read SimpleTalk? Who hasn't heard of SimpleTalk? 2 or 3 people. So SimpleTalk is great. Just go to the website and enjoy the articles. So it's a publication. We have a number of articles and blogs that we list here. It's just a typical website. You might see you've got these sort of tabs at the top. You've got custom RSS feeds here on the right. And it's working. This is my dev instance, which is indicated by the, let's see if I can do this, local development. So this demonstrates to me that it's my local instance, because that's just useful to do, because if I have other staging production instances, I want to be able to distinguish them. Okay. So I'm running out of time, so let's bring up Team City. So Team City is loaded, but with not much in it. So here we are. Let's quickly see how quickly I can do this. I'm going to create a new project. Create project. I'm going to call it SQL in the City, London. Create. A project is just a container for builds. So you can have multiple builds in a project. And I'm going to just create one. And I'm going to call it database. And then now I have to tell it where to monitor. So the repository, the folder in the repository in my source control system to look. So I'm using Subversion, which is why I went to starting Subversion here. And it's loaded it. I need to load Tortoise to find where I've got my database. And this is the scripts folder that contains the database, and which you would have seen if you attended Steve's session. So I'm doing Control-C. I'll paste it into my URL here. Quickly test it just to make sure that everything's fine. Yep, that's good. Can find it. Save. All right. Add build step. So you can have multiple builds in a project, and you can have multiple build steps in a build. I'm just going to create one, which is the Redgate SQL Server build step, which I've installed already, but I haven't configured at all. So I've got a number of things I can do here. I need to specify where in okay, right. Because of a demo I'll be doing later, I'm going to change my VCS route to be, well, let's just delete it and start again, to be one level back from there. It'll become clear later why I'm doing this. So I'm going to go from database backwards. So it means that everything in database and every subfolder of that, if it sees a new file or a change, it will potentially detect that and trigger a build. So let's start again. I'll have to go even faster now to finish this. Right. Okay, let's just skip the testing. Okay, now I need to. So I've got a VCS route. I need to add build configuration. Did I do this before? I didn't save it, did I? Okay, I might be duplicating myself here. Okay, add build step, Redgate. Yeah, I hadn't saved it. Redgate here. Okay. So because I haven't specified the exact scripts folder that contains the scripts, I have to specify that here. So that's just scripts folder, which is my subfolder. And I need also to specify the server. So as part of the CI process, we'll be building databases, deleting them, testing on them. So we need to specify a server on which to do this. So that's my local SQL 2012 instance, and I need to give it valid credentials. Okay. And here we have a list of various continuous integration tasks. So the first one is update a database on every build. It's fairly self-explanatory. Then I've got T-SQL-T, testing, documentation, and then creation scripts and upgrade scripts. So I've got, there's a bit of a glitch there, so that's better. So I'm going to just start at the top and update a database on every build. Why is that showing it like that? Okay. And of course, it's asking me which database do I want to update. So I go back into Management Studio, and I'm going to create a database. And I have a bunch of handy snippets to do this. And this will create a database called Always Up to Date with Source Control. I'm going to do a Control-C there, just so I've got that for later, because I'll mistype it. So F5, I've created a database. There's absolutely nothing in it, because I've just created it now. But to prove it, I'll just open the tables. So you can see there are no tables. Let's go back to Team City, which is here. Paste in that name, and click Save. One thing that I also need to do is create the trigger. So although I've added the VCS route, which tells the build server where to look, I haven't told it what to do when it finds a change. So I do that by creating a build trigger here and add new build trigger. And you can tell it how to trigger. So in this case, this doesn't look good. What have you done? Oh, okay, good. So VCS is trigger on every change it detects in source control, but I can also do it on a schedule, should I want to. So maybe once a day if it's a very long process. I'm just going to save this. And I can also run the builds manually. So I'm going to run it manually now because I haven't actually made a change to source control, so nothing's going to trigger, but I still want to make sure that this database can be kept up to date. So I'll bring that back to the main dashboard of TeamCity, and you can see that there's a build happening. There's a swirly thing happening over here on the left-hand side, and it will take some time because SQL Compare is being used behind the scenes to compare source control to my blank database. It will discover that there are lots of changes, and it will sync those across, and hopefully it will pass. So I'll just go back to the slide just so we can, that wasn't the right slide. So we can just summarize what we've just done. So we've created a project in TeamCity. That's a container for one or more build configurations, and that's a container for one or more build steps, and we've just created one build step called Redgate. So it's a very, very simple setup. So we've done all we need to do to TeamCity. We've set up TeamCity. That was it. And we're just playing around with the options in the Redgate TeamCity plugin to see what it can do. So I can sort of claim that I've already done the demo in case we run out of time, but I'd like to show you every single option. We've specified the VCS route, which was here, which was one level above the scripts folder. We've added a VCS trigger as well. So we're updating a database with schema and also static data. Let's just quickly show you that, because it should have finished now. Yes, so we've got a success here, so we know everything's OK. But to really be sure, we need to check the database and refresh the tables. Fantastic. So I have a bunch of tables. So that's pretty much proof that something happened. If I open country codes, which is my my lookup data, I can let's just select top 1,000, and you can see I have data. So my continuous integration process has built me a database from scratch this time, but if it had been there already, it would have updated it and put in the latest schema objects from source control, and also populated all my static data tables, like country codes and any seed data you might have. So going back to the slide quickly, because I hadn't finished that. So why would you want to do this? So you might have an application, and you might be doing continuous integration with that. That application may have some tests running on it, and the application may actually need this database to function. Maybe it doesn't even work without the existence of the database. So to get a corresponding database for the application that you're testing, and that's probably the core use case that people who currently do application continuous integration will want. But you could use it for a number of reasons. If you just want a latest test database to be out there so that anyone can go into this application, use it with the database just to see where development are at any given time. So it might be a resource for testers, for example. So moving back to the demo, since we're running out of time again. What do we have? All right, I'm really going to have to accelerate now. So let's just move to the next option in TeamCity and see what that is. So okay, so we've done updates a database. Let's do T-SQL-T. Save. So I'll quickly show you SQL tests. So there are some tests already in my database, but it'll be more convincing if I show you a test. Obviously I need to load SQL test, which is probably there already. So the way it works is that we can, here are my tests that have already been detected. If I want to write a new test, I can right-click on the test class, which is the container, and and select new test. I'm going to write a test that tests the performance of a view. So I have a view that is called v_articles, which is the list of articles that you see on the main Simple Talk website. So test perf of view. I should probably put articles view, really. Oh, no. Articles. Create. And this will just create a template, because obviously it doesn't know how to write the test. So it's a blank template with a few instructions inside telling me how I might want to create the test. What I'm going to do is just fill this middle bit with the actual test code. So very, very quickly, it's not important what the test does. This is just SQL. It will just do a select from the view. It does that 5 times, averages it out, and if it takes longer than 200 milliseconds, it will fail. If it's shorter than 200 milliseconds, it will pass. So it's just testing that there's a sort of acceptance threshold for the performance of that view. So if I press F5, I apply that change, and I can now test the view from SQL test by selecting the test, which has now appeared in my tree, and clicking on run test. And it's passed. And I can click messages, and I can see that it says it took 7 milliseconds, which is well under 200, so we're good there. So what we're going to do now is commit the test. The test is just a stored procedure. So we commit it like any other change we make to the database. So we select the database, and it will appear in a couple of seconds. I'll close that down. Added test. I would obviously write a better comment if I had more time. I can see the test down here. It's just a procedure, and I commit it. Of course, anyone else in your team who does a get latest now will get my test, which is great, because the next time they run all they'd make a change themselves. They would run their tests. My test would be part of their tests, and it would ensure that their change isn't breaking my functionality. So it becomes an automatic regression test on each developer's machine. Because I've committed that, if I go back to Team City, I can see that it's kicked off a build, because I've made a change to source control, which is adding a test, and it's kicking that off. And it will not only be, it's not keeping that database up to date because I unchecked that option, but now it's just running the unit tests. And we can see now that we have the test passed. I can drill down into that, and T-SQL-T even has integration into Team City, so I can actually click on a test tab, and it will show me the tests, and I can drill down further into those. So next is generating data. Well, let's quickly summarize that just so that we reinforce it. So T-SQL-T, what is T-SQL-T? We think it's the best free open source unit testing framework. There are a couple of others out there, but from what I've seen, that no one's updating them, and they haven't been updated for a long time, like T-SQL units. So T-SQL-T is definitely the one that you want to use. That's the website. They have a support group via Google Groups, but you can get that information from their website. And SQL Test is part of the developer bundle and provides that integration that you've just seen. So let's move on to data. So where am I? So this is just a checkbox in the testing section, and what it's prompting me for here is to specify the path of a SQL Data Generator project file, which is .sqlgen. So this is a file that tells it what to generate data for. So you wouldn't want to generate data on all your tables necessarily, but on specific ones, and you might want to control what you generate and how you generate it. So we're quickly going to cover that by choosing the table we want to generate data on. So we just find the table, which is articles. So let's see what happens if we select populate articles with data. This launches SQL Data Generator, which is a standalone tool, and it's just going to pass it the context of Simple Talk dev_Steve and the articles database. And the reason why it hasn't happened there is because it's appeared on this monitor here. Let's move that to the right-hand side. And you can see that it's checked the box articles. And by default, it will generate 1,000 articles, but I think simple talk could easily go up to 10,000 realistically. Obviously, I'm not going to put 100 million because that will never happen, or maybe it will in a few centuries, but you don't want to overstress it with unrealistic data. So 10,000 is probably a good upper limit for that. You can select various options here. Does it delete the data that may be pre-existing? There's no data in my database for CI, so it doesn't really matter. Are there any other... I can see down here, it gives me a preview of the data that's generated. So I've got title, which is article title, but it tries to guess for you what the data's like, and it seems to it thinks that might be title as in salutation. And it's obviously got that wrong. I can configure that. I can say, well, I would like to use another default generator, or I can customize these generators. And you just pick a more appropriate one. So here's just a description, which is put, it's not realistic, but it's better than Mr., Mrs., and so on and so forth. So if I want, I can create additional, I can specify additional tables. So I might want 1,000 contacts as well to be generated. And when I'm done, I save this project. And I want to save it. I want to put it in source control somewhere accessible to the build. So I'm going to save it in my working folder here and call it, oops, I didn't mean to do that at all. Lots of data. I save that. Just bring, so you can see what I'm doing. This is just Windows Explorer. If I go to Simple Talk database, I can see lots of data. So this is what I need to commit to source control to kick off the build. So I'm just going to use this to copy the text so I can paste that in to this field so that my build now knows to look for this file in my database folder, because that's the VCS root, if you remember. So I'm saving that there, and I just need to commit this to source control using Tortoise SVN, which is a nice little free tool. Added data to CI, and I've committed that. So let's go back to the dashboard, and that's kicked off another build. While that happens, let's just quickly review what we've done. So why would you generate test data? It's because dev environments are not realistic, and the more realistic the environment, the more likely you are to identify bugs, real bugs that real customers will have. Because production data is not always possible, because you may have some compliance issues with that. Also, random data can result in surprises. So realistic data is good, but random data can test extremes. So if you've ever done some testing, you might have heard of boundary testing, equivalence testing, partitioning. If you generate random data, it will do all sorts of things and produce data that your application may not expect. And that can help you identify bugs and make the application more resilient. And of course, volume testing, because your production database has thousands of customers, and your development machines have maybe a handful because it's difficult to enter data, or at least it's time-consuming. So let's head back to the demo, and we can see, oh, what's going on here? So we've got a failure. So we've got SQL CI failed with error message running unit tests. So let's quickly work out why. We can just drill down, click on the test, and we can see the test that we add is now failing. And this is a bit strange because we ran it in development and it worked. But when we committed it to our integration environment, having added the, having populated it with data using Data Generator, it's failed. So if we carry on drilling down, we can see the message. Let's quickly bring that up. Oh, it's not great, but if you can read that, it says, so it's loading 10,000 articles. This is text I put in the test itself, just for debugging purposes and troubleshooting purposes. Load time is not acceptable above 200 milliseconds, which is my acceptance criterion. And it's actually taken something that's above 226. So is that 5? I don't know. 526 milliseconds. So that's unacceptable. And I only found that out because I have continuous integration in place, running a slightly more realistic environment than I have in development. So what would I do now? This would alert the development team and say the build is broken, fix it. So let's see how we can fix it. So the easiest thing for a developer to do is to try to reproduce it on their machine first, and then fix the issue. So what I'm going to do is I'm going to run this generate data on Steve's database. And this means that my environment will be very, very similar to the integration environment. So that it's successful. Bring up Management Studio. If I have time, I'll just do a select. Okay, we've got 10,005 records, and we've added 10,000, which means that this database only had 5 to start off with. What I can do is load to run this in SQL test again. And instead of passing, hopefully it will show that it fails now because it's taking longer, and this has taken 490 milliseconds. So I can reproduce the issue. I can also load if I still have it loaded, my local development web application. Let's refresh this, F5, and see what happens. Okay, this has failed entirely. And why has it failed? It's not the performance issue. The performance issue would have just meant that the web application would have loaded slowly. But this has just failed to load entirely. And the reason this has failed is evident here. So it's trying to do a convert to date time on date. And somewhere we can see that it says, objects cannot be cast from DB null. So I've generated data, random data, and it's also included nulls in my field. And I didn't expect that. My application didn't expect that. He expected the date, which is the date the article was posted to the site. He expected that to always exist. And maybe there's some validation on the GUI to enforce that. But what I should really do is make sure that if my application doesn't expect it, my data type shouldn't be a null data type. It should be not null. So let's quickly do that fix. And I have a convenient snippet to do the fix for the date. So here, I'm going to update all those records where the date is null to some arbitrary value, and I'm going to alter the column and set it to not null, because it's obviously null at the moment. So F5, I've applied that. If I go back and press F5, it's loading, but really slowly. So you can see swirly thing in the top left-hand corner, and it's because it's just very slow. So let's just go back to Management Studio and see how we can fix it. Let's troubleshoot this issue. So this is the test that's failing. I can double-click on the test, and it opens it up. The bit that does the work is where it selects from the articles. I can right-click and scripts objects as alter. That's a SQL prompt feature. F12 also works as well. And I can see the view. And there was one error issue here. I don't know whether anyone can see it. Has anyone spotted it? No? Not at all? Okay. Someone, I don't know who that could possibly have been, maybe Steve, has decided to put a slow me function in front of the right side of my join condition. That doesn't make any sense at all, but he's conveniently named it appropriately so that I know where the bug is. So that's very nice of him. So slow me shouldn't be there. And the chances are that slow me is the cause. So I'm going to quickly fix that by replacing it with a more optimal version of that view. So I'm going to press F5 now. That works fine. I can press F5 here, and hopefully it should be a bit quicker. But the important thing is to run the test locally before I commit the change, and not just to commit it. So I've got the test here. I'm going to run it again, and it's passed. It's taken 102, so it's still slower than it was before, but it's still well below my acceptance criterion. So what can we do now? We can, it passes on my machine now, so I can say fixed the bug, and we can see that the articles, what's changed in articles? Oh, not null, that's right. So we made the not null change here, and we've also optimized the view. So fixed the bug. So in fact, I've identified 2 bugs. It found one, but inadvertently it found the null bug because it was adding interesting data into the continuous integration environment. So that gets committed, and that will kick off the CI process again, and hopefully it will pass next time around. So how are we doing for time? Probably not much. So let's quickly move on and change the last option, which is, so I'm going to uncheck that just because it'll be quicker. And I'm going to, for speed, I'm going to check both of these in one go. So to create documentation of the database, I have to do exactly what I did before and generate a documentation project file. And I can do this in Management Studio as follows. And I'm going to go through exactly the same steps, so do bear with me if this looks like I'm doing this too fast. So I'm going to save the project. I'm just going to call it doc. Saved that. And it will be doc.SQL doc. Save it. And I need to add it to source control. Add, commit. And I won't bother adding a comment because I'm running out of time. So that should kick off a build. And because I checked generate database creation scripts, it will hopefully generate one of those as well as create the documentation. Validate creation scripts, I won't show you that because it's not very visual. What that does is that instead of just generating the creation script, it runs it. It creates a blank database, runs the creation script, and checks that the outcome is the same as the latest in source control. So it does an extra validation there. It takes a bit longer, but it's worth doing. Generate database upgrade scripts. That's if you have existing deployments out there and you want to create one upgrade script for each of those existing versions. You need to use Deployment Manager for that to work. And the reason is because it has no idea which versions you have out there. And Deployment Manager keeps a record of that. So if you use Deployment Manager, which we covered in Grant and Justin's talk, I think it follows this session, you'll understand how that works in more detail. And the only other bit that I haven't showed you, which is right at the bottom, is where you configure Deployment Manager. And this is, you need to create what's called a database package, which is a bunch of resources that is consumed by Deployment Manager, and you just specify the URL and the package ID, and you're good to go. So hopefully by now, the build will have finished. It's successful. I can drill down. I can see that I have some SQL documentation. So this documentation will now be built every time I make a change, and it can be a resource for developers. I've got a slide that covers that. So that summarizes the bugs that we found in Data Generator. So it can be for developers, DBAs, or business analysts. You can just keep your database up to date. Creation scripts for new installations, and upgrade scripts for existing installations. So let's quickly have a look at to see if we can find the creation scripts. And here we are. So we can click on creation script, and hopefully this will load a script that has lots of create statements in it. And of course, it's loaded on the left-hand side. So this is a bunch of creates. So you can see create table here, and this will build my database from scratch. And had we used the upgrade scripts option, this would have alters in it as well as creates, because each script will have been specifically built for that one upgrade path. So that's the end of the demo. I think I've just managed to do it in time. And so what we've done is we've learned why and how to put automated build and test in place. I've given you a brief overview of the tools that some of you might already own. If they're in the developer bundle and the tool belt. And of course, there are some tools that you can try for free, like T-SQL-T, continuous integration servers, to set up continuous integration. And I have demonstrated, and I'm lucky because this slide would have looked really bad otherwise, I have set this up in less than an hour with lots of talking and slides. So I reckon if you guys went back and tried this, you could probably get this all set up in 20, 25 minutes. So let's see if I've got any slides left. Yes, there is a white paper, which should make it even easier. This, there is a copy of this on the USB sticks. However, that isn't up to date, and my apologies for that. The up-to-date version is on redgate.com/CI. So please use that resource. And I also want to plug, there's a focus group later on migrations, which is a technology that can be used to improve, to customize how scripts are built in a CI process, as well as in a manual process as well. So do attend that at 2:45 if possible. Okay, there's probably time for just one or two questions if I'm lucky. How many minutes left? 1 minute, one question. Any questions?
Yep. With the trigger that you created in Team City, is there any events that won't capture? For example, minimally logged operations?
For example?
Minimally logged operations?
Such as?
Maybe a
BCP. Okay. Are there changes that it wouldn't capture the trigger? Anything that makes a change to that source control repository will trigger as a change. So if that change is converted by either Redgate's tools or some other process into a file that's modified in Team City, it will trigger that change. Okay, thank you very much.